Welcome to the fourth of our series, having a look at the GAGE Android game engine. This particular one, we're going to have a look at how input is managed within the system. Again, we'll sort of look at things generically, then we'll narrow in and have a look at some of the aspects within the code. First thing to say, so if we're thinking about GAGE, you can see on the screen sort of the high level subsystems that we have within it. And our game was our sort of main central repository of all of the different managers. It was our fragment, it contained all the different things, but it also contains the input manager. And that's sort of a set of classes that we're going to delve down and have a bit of an explore of, but it's linked through the game class. One thing to say about input for games, there's lots of different types of input mechanism, from traditional controllers, keyboard and mouse, dance mats, you have audio visual input as well. So there's lots and lots of different mechanisms that you can use to get input into games. We're only going to be interested in a subset of this. And likewise, if you're thinking about your typical mobile device, they now come with a whole swathe of sensors available on them, from ones that can measure the temperature, to your heart rate, to a microphone, to gyroscope and things like this. So we're living in a world that is sensor rich, and most of these are quite interesting in terms of how you can use them. But from our point of view, again, we're keeping things simple. We're really just going to be concerned about a few specific types of input. And again, we've seen this particular one before, that for the game that we're running contains a full screen view object. So we're assuming that most of our input is actually going to be touch based, that the player will be interacting with the screen, and that's where we'll get our input from in most of the input. There'll be a few other classes for things like the accelerometer and so on, if you want to use those types of input mechanisms as well. So as with all things here, big broad area, lots of interesting things in it. We're narrowing down to one specific, relatively simple aspect of it. Just to show you then the code that we're interested in. So here's the GAGE setup. Inside GAGE, you've got the engine package. Inside that, you've got the input sort of collection of files. So accelerometer, handler, compass, gesture, input, key event, key handler, touch event, and touch handler. That's the subset of classes that we are going to be exploring. Inside our main game class, if I search for input here, so this is part of the properties of the main game class, managers and services. We have one for our input. So it's a type of class over here, input. And inside our game, in any game screen or things like that, we can request to get the input from. So this is the subset of classes that we're interested in exploring. If we briefly have a look at through input, you can see it's not that big a class overall. If we just scan down through this here to get a bit of a feel, you'll see that input itself is really just a collection of different input handlers. So we've one for an accelerometer, key presses, virtual or actual keypad on the device, one for touch events, and compass as well. Again, you can add different ones in. Again, you can just add whatever you want into this class. There, when we create it, we basically create the handlers. There's the rest of the stuff in this here, methods like touch exists or get touch X. These are basically just accessor methods, which will return different collections of information from the different handlers. So if we want to get our touch events, we can do that, or get the acceleration on the Z-axis, we can do that. So input really is just a collection of these different individual handlers with some exposed methods that give you an easy way of getting at the information that's maintained by those handlers. That's in essence what it does. Right, so in terms of looking at how they're written, there's a few asides we want to look at first of all, which will help us understand the particular structure that they do have and why things were written in this particular way. So let's go down and have a look at this. First thing to mention, Android, like a lot of other systems, is event driven. So if you touch the screen or interact with the device, an event is generated corresponding to that type of interaction. And that event gets to be created and is then thrown at your program. And you define event handlers that can catch that particular event and then process it to work out, well, what do you do if a touch event has happened? So Android, you get an event handling model. It's very common. I'm assuming you're familiar with it. In contrast, or potentially in contrast, games, they have an update and a draw loop. So you update and draw, update and draw, update and draw, and you do this very frequently. So the type of mechanism used within games is more akin to a polling mechanism. 60 times every second, you'll check to see, do I have input? What is my input? And based on the input in that 60th of a second, you'll take some action from that particular thing. So for games, we have input polling as the mechanism that we're going to be using. And this gives a little bit of tension because we've got these two mechanisms. I touch the screen, I will be generating events. But yet within my game, I will be running a loop that updates and draws, and I'm interested in getting the input for a particular update. So I need to marry these two things together. Now, thankfully, it's not that difficult. So event-driven view, if I'm interacting with my application, I'll have event listeners attached to this here, so that they're sitting there working out what happens. Events are generated, they're passed to an event handler. I can then process that particular event. Game loop, I'm going around my main game, I'm keeping repeating this internal loop, and at the start of each update or during each update, I will ask, give me the input for that particular update. Fine. How do I combine them together? It's really quite straightforward. So what we have here is that I will still have a bunch of listeners that are sitting behind the scene saying, okay, if there's a touch event, let me know about it. And what they will do is when touch events come in, they're added to an accumulator, to a queue. We basically store them. We don't process them then and there. We remember them. We say, okay, we've got a touch input. We're going to store that touch input within a queue-like structure. And then at the start of each update, so when we do our update and draw, at the start of each update, we will go to the input accumulators and we will say, okay, it's been a 20th of a second since I last checked for input. In that period, the user may have provided me with some input. They may have touched the screen, they may have orientated the device. So at the start of each update, we go to our accumulators, which have been storing any input as it's been coming in, and we say, give us the input that has occurred in the last 20th of a second. And that's the input that we use for that particular update. We do our update, we'll come back around again, and then we'll check our accumulators to see, well, do we have any other input that arrived when I was updating and drawing the last frame? And that process repeats then. So we can actually have a look at that within our code just to see how, give you an example of how it happens. So we're going to see this here. So for example, this is within our input class. We have a method for reset accumulators. And I could, we'll find uses just to see where that's used. So this is within our main game class. Anytime we're doing an update, so this is what happens at the start of an update, we will go to our input manager and we will ask it to reset the accumulators. Basically, whatever input you've gathered, let me take that and use that as my current input for this update. So we'll call our reset accumulators, we'll look at that method in a second. We go get the current game screen and we tell the game screen to update itself. And as part of the update, the game screen can go to the input manager and say, hey, give me any input that's happened. Back to our main input class. So the reset accumulators, there's for this implementation, based on the listeners that we have, or the handlers that we have, there's really only sort of two accumulators, one for touch events and one for key events. So we'll do touch handler because it's going to be much the same for a key handler, to be honest. So a bit more of a significant class. Touch handler, it implements on touch listener. Inside this here, we've got a couple of relevant data structures. We've got one for touch events. and this is the list of touch events for this particular update. So we update and draw, update and draw. So the ones that apply, that should be consumed, if you like, for this particular update are stored in our touch events list. Now, when we're doing our update and when we're doing our draw, so that this happens over a period of time, new input could come in. The player could be interacting with the screen mid-update or mid-draw. Any input that arrives in that process, we add it to our unconsumed touch events list. So this is new input that we'll get around to processing on the next update. So we're basically just storing it. It hasn't been processed yet. We're going to add it all together and then we'll swap it over for the next frame. So these are our two lists that basically are the queues, the current queue and then the queue for the next update where we're accumulating things that comes in. We do have a pool because if you're interacting with the screen, you'll generate a whole bunch of actual touch events. So that generates a whole bunch of objects. We don't want to be creating short-lived objects simply to discard them. It's a bit inefficient. So for any of the touch events that we have here that we're creating and storing, we'll recycle those. We'll make use of them within a pool, so we cut down on garbage collection costs for doing this. Relevant method here is reset accumulator. So this is the one that the input class calls, and the input class is called from the game do update, so we'll get around to invoking this. What does it do? It's a bit of synchronization around this, just again make it reasonably thread safe. So what we say there is that touch events is the input that we use. So I have to think about this here. So reset accumulators gets called at the start of an update. We get two arrays. One is touch events and the other is unconsumed touch events. So whenever reset accumulators is called at the start of the update, the current contents of touch events was the input that was processed on the last frame. We want to get rid of that because we processed it on the last frame. We want to only consider new input for this frame. So in essence, what we do there is we go through our list. We're not deleting things, we're adding them back into the pool. So we're recycling them. Once we've recycled everything, we just simply clear our touch events. So it's nice and empty for this frame. And then we then go to our unconsumed touch events. So these were things which arrived in to be processed in this frame. We add all of those into touch events and we clear our unconsumed touch events array. So in that sense, we've done that particular process overall. And that lets us transition between the two. So far so good for this, hopefully. Now, other things that we have to be considered about whenever we're thinking about input, and we'll a little bit on the side here, then we'll go and look at the code just to point out some bits for it. So here we have an example of got our tablet screen, our phone screen. Assume the great big green circle is somebody's put their finger and touched the screen. So it's a touch point. Well, it should only be an individual point, but that's a region, touch point. The types of things that are generated within Android for this here. So we have what's known as a pointer count. And a touch pointer is the number of touch points that you have on the screen. So if I were to take all of my fingers and my thumb and touch it against the screen, I would have 5 pointers, one for each of the individual touch points on the screen. So if I were to get the pointer count, it would tell me there's one touch point on the screen. And if I were to get information on this, each touch point has an ID. So it enables you to uniquely identify that and to consistently identify it from one frame to another if I keep on touching it. So pointer ID is the first time we've touched it, so it has a pointer ID of 1. It has an X and a Y location. So X and Y here is relative to the top left-hand side of the screen. 100 across, 400 down. Fine. If I then take a second touch point, so now I have 2 touch points on the screen, I get my pointer count, it'll tell me there's 2, fantastic. In the start of the array, I will still have the original touch point, position 1, 100 and 400, so this assumes we haven't changed the location, we're keeping our fingers steady. If we were moving it, it would be a different location. And I now have a pointer ID of 2, which is my second touch point, and I've got the location here, 300, 200. Fair enough. If I remove the first touch point, okay, so I touched it first, second, and now I'm taking away the first one. So I'm back to 1 touch point, so my pointer count's going to be equal to 1, fine. And if I query this here, my pointer ID is actually 2. So this can be a source of confusion because pointer ID is a unique thing. So as long as you keep your finger on the screen, you don't change your pointer ID. So because I had a touch point initially and then I touched it, this has a touch ID of 2. And if I take away the first one, whilst there's only 1 touch point now, I still keep the same touch ID. So I can uniquely identify, yeah, this is the same finger that was touching it before. So pointer ID remains at 2, location is wherever the touch location is. Let's assume that I then touched the screen at a different point. So in this sense, my pointer count goes back up to 2. There's 2 touch points. You get an array of these things out. If you were to go through this, it'll say, okay, the first item has a pointer ID of 2. So this is the thing that's been longest on the screen concurrently with the position. And our new one, it comes in and we give it a pointer ID of 1. In this particular case, we don't go for 3, we go for the first one that's free and give it a collection as well. So that's just how touch points work inside Android. Can be a little bit potentially confusing because you've got to keep in mind that at any point in time you will have a certain number of touch points, and each of those touch points will have a pointer ID, but that pointer ID is sort of uniquely associated with it, and as long as you keep your finger on the screen, it maintains the same ID overall. Right, so we can have a look at the code just to see where we do that inside this. And it's very straightforward, to be honest. So if we have a look at our touch event, I'll call out a few things in this here, but there's a few other ones we'll want to have a look at when we go into gestures. So for a touch event, and whenever a touch event happens on the screen, we will extract out the data, package it up into this particular object, and as this object is what we give to our game, sort of encapsulates all of the information, relevant information, that happened for the touch event, so our game can process that. So things that we have that relate into what I was talking about just shortly is each touch event has a XY location, so the screen location in which it occurred, and it has a pointer, and this is the pointer ID associated with the touch event. So, you know, this is the first or the second, or again, this is the thing that helps you identify for a touch point what one it is from one frame to the next. So you'll see both, as you're looking through the classes here, XY and pointer ID, that's the things that they are referring to. We'll look at the other things very briefly. Anything else you want to look okay, no, okay. Other things then. So again, a little bit of background, and then we'll eventually go through the code in a bit more detail. If we're thinking about a polling mechanism, so we're going around updating, drawing, it has some advantages, also has some disadvantages. The advantages are that it's a fairly low level amount of control. You're doing this very frequently. It works well with the update draw mechanism. You can respond to things quite quickly. The disadvantage of this update and draw is you need to think about types of input, if the game supports it, that happen over a period of time. It's not, you know, if you're doing 20 frames a second, it's a 20th of a second. But if I'm swiping across the screen, I may be doing a particular gesture, that gesture will occur over the period of half a second. That's 10 updates. So for that sort of polling-based mechanism, it's a bit more challenging if you've got gesture-based input or inputs that occur over a longer period of time. In your game, you've got to be able to build up and infer and to detect those over that longer period of time. Now, thankfully, in Android, we can actually we can see some of them here, and there's sort of classes that are built in that will help us do this. So just go through these here. Tap, briefly tap. That's a fairly quick interaction. Double tap. Again, I think of a double tap, even if you try to do it quickly, it may take a fifth of a second. That's several updates. So if we want to detect a double tap, we'll need to do a bit of work on this. For a drag or a flick or a pinch or a spread or a press and tap. So again, you can see the different types of gesture that often are used on sort of touch-based displays. For your game, not all of those are going to be relevant. Some of these you may want to use, some of them you may not want to use. But we should think about, well, if we do want to include some gesture detection inside our game, how much work do we have to do? And actually Android here can actually help us out with that. So to go through these here, so we had a touch handler. Let's have it, actually we'll go through the class, and then we have over here a nice class called a gesture handler, which we'll build on top of it. Gesture handler is a class available within Android that we can then use to help us detect gestures. But let's go through and have a look at these classes, and we'll see how the whole thing fits together. Right, touch handler, it implements on-touch listener. So this is going to be basic touch input. I'm not going to include gesture quite yet, we'll get onto that. We say what's the maximum number of simultaneous touch points that we can support. So if I were to take all of my fingers and thumbs and press them on the screen, that's 10, that's a sufficient number. I have some variables defined here, so an array of bools that are true or false, so that this let me know if I have a particular a touch ID or a touch point on the screen. And if I do, if it is set to true for that particular one, I can then get access to the X and Y location of it. So I'm extracting this out because this is not sort of event based in the sense of here you've got a new touch event or a press or a release. This sort of represents at a snapshot in time what touch points do you have on the screen. And for some games that's the sort of view that you want to get. We've already encountered these ones down here. These were our pool of touch events. One's to be processed in the current frame, one's to be processed in the next update frame. There's a little bit of scaling. It's not really used currently, but if you did want to scale from, so if you touch the screen, the XY location is actually based on the resolution of the screen, the native pixel density. Sometimes you might want to scale that down to uniform overall setup if you want to sort of standardize your input. Pool size of 100, which means we'll store up to 100 touch events just inside the pool. If we create things, we create a new pool, we set our scales to be 1. This one here, so basically whenever we're creating it, you can pass in the view object. So a touch handler normally is associated to a view. That's where it gets its input from, so that's the one you want. So we'll call the default constructor, and we'll go to the view. In our case, this will be the full screen view, and we'll say to it, right, well, you do support a touch listener. I'm going to attach this particular touch handler as your listener. So there we're listening for any touch, any input events that we get on the view object. That's how we'll get input in when the user interacts with the view. You can set change the scale. Here's the overridden on touch method. So because we are a touch listener, we have to implement this particular method. When it happens, it's passed in, we get the view object that generated. In this case here, our handler is only attached to a single view. We don't have like a handler that's attached to multiple view objects, so we're not really going to bother with this. And we get the Android motion event that happened. Now this is the thing that we're going to extract our information from whenever we're building our touch event. So we got a method update position, so we'll see that underneath. We extract the type of event that happened, and we extract the pointer ID. So this is associated with this. This is the pointer ID. Remember, this is the point that enables you to identify what type of touch location or touch point this is. There can be a little bit of instantiation here if we have to get a new touch event. We don't want to create a new object. We'll go to our pool and we'll get something from that. And then we've got a switch depending on the event type. And if it is a down or a pointer down, we do the same type of action. We don't differentiate between these. We say that our touch event, the type is that it's a touch down event, which it is. We update based on the pointer ID to say that we now have a pointer ID that's live, is set to true because we've got an event in that tells us that it's happened, and we break out. If it is a move, so we have been pressing it and we're moving our finger across, then we create our touch event with that particular ID. If it's an up or a pointer up, then again it's touch up, and we set our touch array back to false for that particular one. So that little bit of code there simply generates a few events for a down and an up, and updates our array of touch points. That's all it does. At this point here, we go to the method, we'll see it implemented underneath, where we add it in. So we've created a new touch event based on the event that happened. We store it, so in the next update we can get access to it. Update event positions, it just simply iterates through to work out, well, do we have a pointer ID 1, 2, or 0, 1, 2, 3 up until the maximum number? And if we do, we update our array for that, apply some scaling if we want to do so. Instantiate touch event, simple method that we'll go to the pool, we'll get out a new event from the pool. If the pool doesn't have any left there, it actually will create a new one. We've got a little bit of initialization to do, because what we get out of the pool could be a dirty object, could have data left over from last time it was there. So we store the pointer ID, we store the X and the Y location. There's DX and DY, which is movement based. Now, it's actually used for some of the gestures if you're doing sort of a drag or you're moving things around, but by default for simple touch based things it's set to 0. There's no sort of tracking of change, and we return it. For utility methods, we can work out if there's an existing touch. We can get the X location for a particular pointer ID, or we can get the Y location for a particular pointer ID. Add touch event, so again this is called at the bottom of the event handler. It simply says go to our unconsumed list of touch events and add the thing in, nothing more than that. Get touch events, so this will be called by game screens or other things, where you can go to our input manager and you can say, well, I would like to know what touch events happened for me to process. So all this one says, if you want to get touch events, you return the current list of touch events. This method assumes that you're not going to be changing the touch events mid update. And reset accumulator we've already had a look at. So a fairly straightforward and simple method overall. Gestures then. So we mentioned that these occur over a period of time. In an update or sort of update draw point of view, there may be work involved, but thankfully in Android we actually have a helpful gesture handler that we can, a class, a gesture detector that we can use to manage that for us. So what we're looking at here is a gesture handler. It's a type of touch handler, so it's a more refined one. It can detect the basic touch events and then some more. And if we were to check within our input class up at the top, so you can see here whenever we are creating our different handlers. So we're going to create a touch handler. We don't create the basic touch handler, we actually create the more fancy gesture handler. So let's have a look at our gesture handler. So it's a type of touch handler, does the basic stuff, but goes beyond it. In fact, it implements the gesture detector on gesture listener. So inside Android, for different types of events, you also can have gestures being detected, and if we have a listener, we can tap into those and work out when they happen and then do something in response. We need to have a gesture detector to actually do this for us, but fair enough, that's where it saves us doing it ourselves. We create this here, same constructor as before, got to be linked to a view, so we call the superclass, does the setup. One difference we do here is that we actually create a new gesture detector for us. So it's Android class, it will detect these gestures and call the event handler when need be. And for the view that we're attaching this to, well, we set this up as the touch listener. So far so good. On touch method that we have, so this is basically the normal one. What we do first of all is that so the motion event happens. we give this to the gesture detector because it's looking out for gestures on our behalf, and we let it work out, okay, here, have the motion event, process this, and let me know if it has been consumed or not. So if it's been consumed, it's mean the gesture detector has worked out, yeah, this has resulted in a gesture happening. I'm going to call that, or I'm going to generate my own event around that. If it comes back as false, the gesture detectors looked at it and thought, well, I can make nothing of it. Here, you see if you want to do something with it. If it hasn't been consumed, then we just call the superclass onTouch method, and it'll do the regular, press, release, drag setup. And we return true because we have consumed the particular event. What we have then are basically the overridden methods that if we have a down press, we don't need to do anything because the superclass does that. If we have on show press, just go through these. On long press, so if you hold the button down for a long time, on single tap up, on scroll, on fling. So these are the gestures that we're picking up that the gesture detector will recognize. And in all cases, we're just storing appropriate information depending on the gesture that happened. And it's all picked up in our touch event class. So touch event, these are things that are generated. You can see here for the different types, we know if it's a down, an up, if it's dragged, if it's a long press or a single tap, or we're flinging things across the screen. So these are the ones inside the game that we can detect, and you could extend it to add other ones in. Or type over here tells us the type that it is. X and the Y give us the location. DX and DY, so these are the deltas from one event to the next event. So if we're doing with a scroll, or if we're doing with a fling, so these are different types of gestures, then the DX and DY will give us, well, how far have we scrolled, or how quickly has the fling actually happened. And we can look at those values inside our game to work out, well, what do we do as a consequence. Over here in gesture detector, so for example, on scroll, that'll be one of the ones. So we create a touch event, same as before, set it to be the scroll one. Here we actually are updating the X and the Y, the DX and the DY rather, to store the distance that we've scrolled so we can actually take some action on that. And that's all that class does. So this is all reasonably straightforward. We'll run the thing just to let you see some of this happening. Okay, so if we go into our input, it says interact with the screen. Now, some of the things you can see here, the accelerometer, so this is running on an emulated device, so it is sort of mock gravity. Pointer ID, now it can support up to 10 pointer IDs. I'm only displaying 5 on the interface for reasons of brevity. If I touch the screen, you can see then that, okay, so we have a pointer ID of 0. Now, unfortunately, I've only one mouse, and the emulator doesn't really do multi-touch, so I'm not going to get anything other than a pointer ID of 0. So release, touch, release, touch. So it can detect an ID of 0. If I could do multi-touch and I touched it again, I have a pointer ID of 1 being triggered. But you can see it's detected. It gives the XY location relative to the top right-hand side of the screen. And I go down to the bottom left, and it is the pixel density. So this is emulating a sort of an HD screen. So move around it again, it changes. So these are pointer IDs. You'll notice a whole bunch of stuff happening over here on the other side. These are the events that get to be generated. So if I do a simple click, actually let me go back. We will go in input, single click. Oh, that was more. That was okay. Okay, there you go. So I clicked, but I actually dragged the mouse down. So that small interaction happened, I don't know, a fraction of a second. It generated a total of 6 events. So events, generally speaking, are generated quite quickly. The initial event was a touch down at this particular location for this pointer ID. Then I didn't release, I actually was dragging my mouse down. So it detected that I was dragging with the mouse clicked down. So then it generated an event for that. Because I was clicking and dragging down, that looks a bit like a scroll. It's the same type of thing you would do if you were scrolling up and down. So a touch scroll event was generated. Another touch drag, because I was obviously dragging down for a sufficient length of time for it to generate a second one to tell it I'm still dragging the thing around. At this point, I will have actually done a touch up. I will have released it. So that's my touch up. Because I released it whilst the mouse was still moving, that looks like a fling. I sort of picked it up, moved it across, released it. It looks as if I'm throwing the thing across the screen. So that small interaction generated all of those different events. Again, if I'm dragging down here, you can see that I'm scrolling and dragging, and both of these events are sort of appearing concurrently on the screen. So as you do interact with the screen, there'll be a whole bunch of different things that are generated. If I hold my finger down, you'll see there that there's a few things that take a little bit of time, just a fraction of a second, to appear. So press down, we have a touch down, a show press, a long press when I hold it in a bit longer and haven't moved the thing, and then a touch up. So that's our gesture listener, recognizing those things and generating events for them. So that's all that does. Other classes that we have here. So that covers the touch event we've had a look at. Touch handler, you've seen. Gesture handler, you've seen. Not going to, again, you can go through these things yourself. So for a key event, if you had a hardware or software keyboard on the screen, you can click on those things. You got key up, key down. So depending on the type of event that happens, key code, depending on which code was pressed, and just the char associated with that. The key handler is actually fairly similar to the touch handler. Also has a bunch of keys you can press. Sims no more than 128. You could have more. Again, there's a pull here because we want to recycle our key events. We attach it to a view, same as before. We've got our on key listener, and again, it just simply stores information for that within a key event. Not much more than that. You've got some utility methods for getting things out or getting key events and resetting the accumulators. The other two are the accelerometer handler and the compass handler. Compass handler, fair enough, if you do have that installed in the device, will work out the particular orientation. Accelerometer handler, so it's a type of sensor event listener, has X, Y, and Z axes accelerations along that. Again, you create the thing, you need access to the sensor manager. On accuracy change, so if something changes on it, this gets to be called. Not really used in that there. On sensor changed, anytime there is a sensor event change, so person's oriented at the device differently, that gets to be called, and we'll extract out the particular values of it so that they can be accessed within our update. We're not using accumulators here, so this is just live data stream. So whenever you access it in an update, you get the value that it is. It is entirely plausible that actually this value could change mid update. That's more or less all that we have in the class. Not really much more to do beyond that. So just to wrap things up then. So mobile games, there's lots of different sensors available on them, but for a mobile game, most instances you can serve a simple touch-based input. If you make it a little bit more fancy, you may have some complex gestures, but that's about the extent of it. For games, because of the update and draw loop, you're kind of in polling territory, which works fine. We need to have a little bit of linkage for an event-driven model so that we can present this in a sort of controlled manner as part of an update draw loop. But we had a look how we do this. And for things like gestures that happen over a longer period of time, again, we actually find that Android has a number of built-in classes that can help us out. We don't need to do that ourselves. So hopefully that gives you a bit of an overview for how the input classes are structured inside GAGE. For how you want to use it, actually I'll go back to the code a second because it would be useful just to have a look at the demo on this one here, because this actually will show you how the thing can be used. Update, we're getting it. So there you go. So most of your particular screens, you'll go to the game because it contains all of the different managers. You'll say, give me the input. and you get access to the input manager. If you wanted to access the accelerometer, you get it directly out. If you wanted to work out if a specific touch event happens, you can access that directly. If you wanted to determine, well, what touch events did happen on the frame, you can get those particular things and then cycle through them. Depending on the type of event that's happened, work out what you're going to do as a consequence for it. So in essence, using it inside a game is nothing more than going to the input manager and calling the methods that are available. It'll give you the input. You can then decide what to do.